morning, everybody. My name is Ehud Carmi. I'm from Israel, and in the next 20 minutes, we will talk. Can I talk? Good morning, everyone. My name is Ehud Carmi. I'm from B.Sc, Israel. I'm Chief Agronomist. And in the next 20 minutes, we'll talk about soil, water, hemp, nutrition, and relation between. We'll talk about cultivation in open field to understand all the media and all the environment that surround and give the plant itself the ability to grow and to give us better yield and better results. Sorry. First, we'll talk about the soil. We'll try to understand this media. It's a living, breathing, natural media composed from all those three phases that we use and needs for our crops. It provides habitat for the plants and for all kinds of organisms for us, and it serves as a water tank. Let's say it serves as a water and oxygen air tank for the plant to grow up, and it's a medium to our crop, the most important medicinal solution for humanity. If we will go inside and we'll try to define the soil structure per particles, we'll see we have like clay particles, we have silt or a loam or a sand particles. With them we can find organic matters, we can find the air and the water. And the organic, the plant took its nutrients. The play between air and water, it gives it the ability to breathe and to take out its nutrient requirement from soil and water and the relation between. Just a minute. If we will try to define the main three types of soil, the medium, we have Mr. Sand, Miss Loam, or Miss Clay, and we try to define their types. We see that we have, as it gets heavier, its volume weight gets lower, and its pore volume between the pore, and we'll talk about it later, the pore volume getting smaller because they're as bigger as if we'll go back to our this slide, we'll see here as bigger as the pore, the particles, the air between them is the pore are bigger. So this is the difference. And if we will see about the saturation water content, it seems that this is going relatively. As more it's small particles, it's heavy soil, its water, a bit saturation content, it's higher. Why? Its ability to hold water is bigger. So now you ask, what is better for us? It's depends on relation between what you have in your place, what we can make it better, moderated, and how we can give it nutrition and water requirements. Let's talk about it. If we go inside to give the ideal soil structure, we can see that 50% from it can be solid, like 25 can be water, 25 like the air, and 5 it's for the organic matters, part of the solids. This is give us the best solution that the roots can breathe and can take water from solid and can take its nutrient requirements. If you want to find it by water retention in different soil, we can see another type, as big as, look here, as big as the particles. The pores are bigger, the water going down fast by gravity, and it doesn't help so good by the soil. So it means that we need to give more water. As smaller the smaller the particles, there are more microspores, and they hold enough water and against the gravity and force of the gravity. Later, if you have any question, I'm here for you, friends. If you will try to define better, to look it from another form, about three main positions, as we say wilting point, we see field capacity, and we see a saturation point. You can call it, as I told you, when it's full of water, full of rain, it's drained out by the zone rapidly, with gravitationally, there is enough water, but the plant, it's got less ability to breathe. If we are in field capacity, more or less, the plant, the micropores cannot help better the water, and it's more valuable, and the roots can absorb them better. When we are in a wilting point, no water, the plant root system is very poor, and it's impossible to get. It's getting bad, and the plant is trying to lose its ability to grow. We can see it is here. We can see here the roots in a wilting point. It seems that it's a very bad situation. Here we can see it's full of activity. It looking better, and the plant is looking better. If you want to understand the nutrient transport to the roots in mass diffusion, it's active in diffusion first. What it's going out, we can get water from air. We can get water from irrigation, from drip line, like here. And by the water, when it gets to its root zone, and the plant start to fill it and start to take its nutrient from soil. What is the conditions about, we'll talk about later. The form that we can give our fertigation of fertilizer. We can give it in a quantitative form related to the water and to the nutrient concentration, or proportional ppm by the water in the water, always in the same concentration. It's always we have to adapt it to soil quality and irrigation techniques, what we have. Now let's talk about a little bit the nutrients and their role in the plant nutrition. Later we'll make some fertigation program to see what we can do from it. If we'll talk about nitrogen, we can see it's improve the plant growth. It's improve the plant growth during the vegetative phase. How it's doing? We get, look, nitrogen, it's like 70% in our air. It's fully in soil. It's one of the main that we need and the plant needs. How we take it, which form we talk later, but it's improve how it take from the roots. And then it's go, if we think like in the plant, there is a lot of cells. every cell get inside, you injecting like nitrogen, and it make it bigger and bigger. This is, it's improved, it's this the form, it's improving and control its growth. It's so it's a component, very important component in the structure of the radionuclides of the chlorophyll and fatty acids and more. How we can define its deficiency? If there is irrigate too much, for example, and the plant can't take nitrogen from soil, we can see chlorosis, but very yellow in this form. Look like this better. We'll see later. It's another. It's different in other crops. If we'll talk about phosphorus, the other two, phosphorus. Look, it's make first. It control the root zone. It makes the root zone in the soil. It makes it more acid. When it's making it more acid, for the reaction of the roots, it's easier to take all other nutrition, all the other microelements from the soil. It's like it's give them the sign for the flowering and for it's essential for the seeds. So it good. It's most important for flowering, for roots development, for plant growth to get inside all the other microelements, and it's most important for its meristematic diffusion. And if we'll see talk about its what's making deficiency in the leaves, we can see when deficiencies means that leaves more between purple to yellow, not in the same form as we saw before. We can see how we can define it here in the leaves of the hemp. And more part important, it's a component in some amino acids and chromosome. It's most important to the photosynthesis process and to the structure of phospholipids and etc. Here again, the third member of the three main macro elements is the potassium. It's improved hemp quality. It always, if we said that the nitrogen make it bigger, the cell, if we inject the quality, if we try to think we inject potassium, it means that we inject to give it more, make it stronger inside. It participates in enzymes activation that active in the photosynthesis, and it's most and metabolism, and it's most important to possess carbohydrates from leaves to roots and ions from roots to leaves. How? Its most important role in the water system transportation from the roots and from the roots to the leaves and out, and it's take part in the evaporation process. When we talk about potassium deficiency, we can see another time a little bit. We see a chlorosis, but look, it's how it appears in the banks of the leaves. How it appears in the banks of the leaves. There is two more. There is two more microelements most important. It's calcium and the magnesium. The calcium, as we know, as for us, it participates in the cellular structure and its division. It's a low reaction, some reaction in the cell, in the plant itself, and its place. It's most important to be a detoxifier of the boron. We'll talk about the boron role and how it is so important. When we see, if we later, so look everywhere, the difference in the form of the chlorosis between every plant or every leaves, we see the chlorosis is between the nerves, we can see, or veins of the each plant. It's not the same form or definition. Sorry. If we talk about magnesium, it's a large element of the chlorophyll. It's most responsible for the photosynthesis. It's participate in some other, as you see, some other synthesis processes, activation, and it's improve the potassium absorption and translocation in the plant. If you want to see another time, we can see here, but just, oh, sorry. If we'll see here, look, in the vein, we'll see the chlorosis. It's bit like the calcium between the veins, but we can see that it's smaller necrotic, it's smaller points. It's not the same form. It's not every vein. It's here or there. More elements, micro elements for us, most important for us to the process is the component of, it's the sulfur. You can see its participation and its role in the plant, the hemp producing. You can see how its effect, how deficiency of sulfur can appear. Maybe a little bit seems not like, but not most like of the nitrogen. You can see there is a little bit different in its appearing. We can see the iron is the most important component in the photosynthesis in the chlorophyll. Look, most of people see when they see chlorosis of nitrogen, they think, oh, they say iron. No, no, no. Iron is going faster by water down in the soil. But first, when there is no felt of nitrogen because it's full of water, of course, we will see iron. But not first, we will have to give some nitrogen. But you can see how it's appeared in the bank of the leaves. Bore, I told you before, bore, it's a component that we put in, we give in small quantities, minutes concentration in the needs for the plants in fertilizer. It's less than 0.01%. But if we have it, we need it to activate some enzyme to precipitate in some leachate production. It makes thickening the cell, the wall, the forms. And but if we have too much, it can be a toxifier and it can kill the plant itself. Look what can see too much boron for young leaves. Now, after we know some more details about the nutrients, we can more or less give some more recommendation for our needs to as a fertilizer. You see the numbers below. I won't take it, but you can see nitrogen, phosphorus, more related the same, and potassium we need double. Everything it's of course related to the light structure of the soil, and we have to see always to take soil analysis to see how we can change it. Another in the form of using to fertigate, formula, or more or less how to use quantities during our cultivation. And for today, I hope this uh, this lecture was interest for you. If you have any question, anything that you want, need consultancy, you can always connect me and ask me. I'll be glad to help you. And thanks to Jackie and staff, everyone here. It was nice for me. Have a nice day, and hope you share you enjoy your other lectures too. Thanks. Bye.